what we're going to look at in this video is just an introduction to chemical bonds. So a brief definition of chemical bonds. A chemical bond is the force that holds together two or more atoms and makes them function as a unit. So basically, most of the time, these elements that we're talking about are not just floating around by themselves. They actually form bonds. So there's a force that connects those elements, and then those atoms or elements will function as a unit. So you're probably familiar with this from a biology class. So if we look at something like water, that's H2O. You're not going to find water on the periodic table, but water is oxygen forming bonds with two hydrogens. So the hydrogen is bonding with the oxygen, and that's a force that's holding the oxygen and hydrogen together. Now, I just want to introduce this idea, and we may talk about this more later, but there's something called bond energy, and this measures the energy required to break a bond. So it's a measure of how strong the bond is, and we'll refer to that maybe a little bit later. All right, so why do atoms form bonds in the first place? Well, this all has to do with valence electrons, and that's why I've been introducing these concepts. So valence electrons, if you recall, are the electrons that occupy the outermost or the highest energy level. So these are the furthest from the nucleus. They're on the outside of the atom, and these are what are interacting with the rest of the world. So if you remember when I introduced valence electrons about a week ago, I said that these determine the chemical character of an element, and that's because they're the ones that are actually on the outside interacting with everything else. Now, the most energetically favorable electron configuration, so that's basically the arrangement of electrons in the orbitals, is when the valence energy level is full. Now, why this is the case isn't quite clear, but we know that if the valence energy level has all of its slots filled, so all of its orbitals are holding two electrons, we know that that's the most favorable configuration. So what atoms are doing is they form bonds to fill their valence energy level with electrons. So again, why do atoms form bonds? It's to fill their valence energy levels with electrons, because that's the most energetically favorable configuration. Okay, so what I want you to do is draw the orbital filling diagram for fluorine, and you can pause the video to do that. And I'm going to do it right now. So fluorine has 9 electrons because its atomic number is 9. And so if we fill in the atomic orbitals for fluorine, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Now what you'll notice is the valence energy level for fluorine is the second energy level. And I ask this question, how many electrons are needed to fill the valence energy level for fluorine? And if you'll look at the orbital filling diagram, if we had one more electron, then fluorine would have a full valence shell or a full valence energy level. So the answer is fluorine would need 1 electron to have a full valence shell. Here I meant to say sodium. I just copied and pasted and didn't change it. So next, what I want you to do is draw the orbital filling diagram for sodium. And you can pause it and take a minute to do that. And I'm going to do it right now. So sodium has 11 electrons. Its atomic number is 11. So I'm going to draw 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, the valence energy level for sodium is the third energy level. And if you'll notice, it only has one valence electron. So I ask, what would be the easiest way to achieve a full valence energy level for sodium? If there's only one valence electron, rather than adding 7 more to fill the third level, the easiest thing to do for sodium would be, well, let's just give this one away. And now our highest occupied energy level is no longer 3, but 2. And if you notice, the second energy level is full. So one of the strategies that these atoms can use is they can dump or give away a valence electron in order to get a full valence shell in the energy, energy level below. So again, looking at this idea, why do atoms form bonds? It's in order to fill their valence atoms form bonds to fill their valence energy level with electrons. And so we have a couple of rules of thumb that we use in chemistry that take this into account. So the octet rule says that main group elements tend to bond in such a way that each valence shell contains 8 electrons. So that would give them a full valence shell. Octet is the prefix for 8. And in the main group, there's a couple of exceptions, and we call this the duet rule. Duet means 2. So this applies to hydrogen, lithium, and beryllium. Each forms bonds in order to contain 2 electrons in the valence shell because their valence shell is the first energy level, which only holds 2 electrons. So most of the elements we're going to be talking about are trying to get 8 electrons in their valence shells, with the exception of these 3, which are trying to get 2. But either way, they're trying to get a full valence energy level. Now, one of the ways that atoms do this is through something called an ionic bond. And in an ionic bond, elements or atoms will completely transfer their valence electrons from one atom to another. So this involves what we call an electron donor, which is usually a metal, and an electron acceptor, which is usually a non-metal. So if we look at an example, so we have lithium and fluorine, okay? So lithium, ignore the plus and minus for now. Lithium has 3 protons and 3 electrons, and fluorine has 9 protons and 9 electrons. Now the valence energy level for lithium is 2, and it has 1 electron in its valence shell. The valence energy level for fluorine is 2, and it has 7 electrons in its valence shell. So in an ionic bond, we just have a complete transfer of the valence electrons from one atom to another. If lithium gives its electron to fluorine, then fluorine now has a full valence shell in the second energy level. And if lithium gives its electron away, now its valence energy level is the first level, and it's full. It has 2. Here's the result. If lithium gives away a negative charge, it has 3 protons, but after it gives this negative charge away, it only has 2 electrons. And that's where this plus comes from. Because it has more positives than negative, it has an overall +1 charge. Along the same lines over here, Fluorine has 9 protons, but now if you count, it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. So because it has one more negative than positive, fluorine has a negative charge. And what did we talk about earlier in the year? If you have opposite charges, opposites attract. And so you get lithium fluoride because the positive ion or the positive atom is attracted to the negative. So that's an ionic bond. Here's another way of looking at it. This is using orbital diagrams. So lithium has 1 electron in its valence shell. Fluorine has 7 in its valence shell. So if lithium donates its valence electron to fluorine, now lithium has a full first energy level and fluorine has a full second energy level, and so they both satisfy the octet and duet rules. So they completely transfer the valence electrons from one atom to another. And then all we have is opposites attract, and you get the compound lithium fluoride. The same thing would happen in the example we used. Here we have sodium and fluorine. If sodium can give its valence electron to fluorine, then fluorine has a full valence shell, and sodium has a newly formed full valence shell, but sodium would be positive, fluorine would be negative, and they'll come together to form an ionic bond. Now, there is a pattern on the periodic table. Elements in the first column, or the first group, all have 1 valence electron, and so they're all able to give away that valence electron and form +1 ions. An ion is just a charged atom, so they can form +1 ions or charges. Everything in group 2 has 2 valence electrons. So they can give away those 2 electrons, and then they end up with a +2 charge. In the third column, or the third group, they have 3 valence electrons. And so these have the ability to form +3 ions, or charged atoms. Generally speaking, nitrogen or groups 4 and 5 aren't going to form ions. But if we go over here, the 7th column has 7 valence electrons. So these are going to tend to want to gain 1 electron and form -1 charges. Whereas the 6th column has 6 valence electrons, so they're going to want to gain 2 electrons, and then they'll end up with a -2 charge. One last thing I want to point out, the last column is called, this group is called the noble gases. So these are chemically inert. They already have, with the exception of helium, which has 2, but that satisfies the duet rule, but these all have 8 valence electrons. So these are called chemically inert, and what that means is they're not going to react because they already have full valence shells. So they have no need to fill their valence shells because they're already full. So things like helium, neon, argon, generally speaking, don't react with anything. Okay, that's where I'm going to stop. This was just supposed to be an introduction to chemical bonding. The thing that I wanted you to get out of this is this concept right here. Why do atoms form bonds? To fill their valence shells or valence energy levels with electrons.